All right, guys, for 2.6, we are continuing on this exciting journey of getting you guys used to proofs. So our first real introduction to proofs took place in 2.5 when you guys were asked to do a paragraph proof. That was supposed to be a way of trying to get you used to just the process of a proof, but sort of doing it in your own words rather than doing like a formal two-column proof like we're going to see here. So the way this is going to transition in this section is now we are introducing you to a formal two-column proof process, but we're using concepts that you already know. And so the math part of this will be very simple. This is more about getting you used to just how a proof works, the order that you write things in, what goes where, all that fun stuff. So this will be great practice in just sort of getting you used to the process of doing proofs, just using basic algebra that you guys already know. So quick reminder of all these algebraic properties. You guys know all of these, with the exception of potentially the reflexive, symmetric, and transitive properties. So I'm going to go over those with you guys first, but the rest of these are just basic algebra steps. As you guys look down at a problem like this, right, if I'm solving this equation and I just said, here you go ahead and solve it, you know, what's the first thing that you would probably do? Most likely you would distribute the 2 into those parentheses. And so when you get the new line, it's going to look like this. But the key on these is to go with every step that you take, you have to give a reason for what allowed you to just do that. And so if we said what reason allowed you to do this step that you just took, we would say I used the distributive property. So the way a proof works, and you're kind of seeing it down here below, is the left side is the actual math process, and the right side is where you give your reason for each step that you take. So before we go through these guys, I wanted to show you 3 properties that you just may not be as familiar with. One we have talked about. I threw it into 2.5 and it came up in the homework for 2.5, and that's called our transitive property. The transitive property goes like this. If A equals B and B equals C, what conclusion can we make based on this information? Well, we've said that if A and C both equal the same value, then they must also equal each other. So our conclusion would be that A equals C. And this works for angles, it works for segments, it works for all that type of stuff. So we can apply it to any of those. And we did that within the 2 paragraph proofs from 2.5. So that one you should be a little more familiar with because we have talked about it. But these 2 should be new. The reflexive property, they're both very simple. The reflexive property simply states that something equals itself. 5 equals 5, x equals x, all that fun stuff. So it's a very, very simple property. You just need to know the name of it. So whenever this comes up within our proofs, I want to make sure you recognize it's the reflexive property. The way I've always remembered it is think of it as looking at your reflection in a mirror, right? If you look in a mirror and you see your reflection, right, it's you looking back at yourself, right? So it's 2 equal objects staring back at each other, right? So you're looking at your reflection. That's the reflexive property. The symmetric property is that what allows you to switch the order of something. So if A equals B, then B must equal A, right? And so symmetric has to do with switching the order around. And so those are some of the 3 that are going to come up again in this section. So we'll be looking at those. The rest of these properties are all very basic algebra properties, and we're going to address all these as we go through these practice problems. So let's just take a look at the one that they did for you first, so I can remind you of this process that we talked about in 2.5. And then you can kind of see how this works, and then we'll do some fill-in-the-blank problems together. So, super important. Every proof that you ever do must always start with the given information. In this problem, we have been given this equation. We are told that this equals 30, right? That is the information that has been given to us, and so we must always start with the given information. The last line of the proof is always what you are trying to prove. In these cases, we're simply trying to prove what x equals. And you can see that down here. So like they clearly state what it is you're trying to prove. So we know what we've been given. We know what we're trying to prove. Our goal is to figure out how do we get there? How do we fill out the step-by-step process in between in order to come to that conclusion? And so that's what we're looking to do. With every step that you take, you have to give a reason for why you took that step. Your first reason should always be given, right? So that's just simply the reason. That this is what it is because it was given to me. So your first line of the proof should, on the left side, be the given information, and on the right side, your reason is simply given. So this is all I would write for my reason. So we already talked about the next step. If you were going to simplify from here, most likely you would distribute the 2, right? And so this would be your next line. And with that new line, we have to give a reason for how we got there. We simply use the distributive property. From here, what would you do? From here, we would combine, most likely, you would combine the 6x plus the 2x to get 8x. This is one of those properties where I don't know why they say the substitution property. As I look back at their definition of substitution, this process does not seem to fit substitution. We are simply combining like terms. In the previous book that we used, the 2 explanations that book allowed for this step like this were combine like terms, or you could say simplify. I like those 2 a lot better. So here's what I'm going to say. The book is using substitution. So if you want to use substitution, I will allow it only because the book allows it. But what's kind of funny about this is you see all these, they say property of equality. The reason they say property of equality is because these are things that you would do to both sides of the equation, right? So like when we say addition property of equality, it's because we are adding the same value to both sides of the equation. So I really don't know how they come up with substitution property of equality for this step. My personal opinion is that's not what I would have used. I would have either said combine like terms, or I would have said simplify. Whenever you're doing something on simply one side of the equation where you're just simplifying it, you're just combining like terms, I think that's a better answer. So I would have said simplify, or I would have said combine like terms. So I will take any of those. So as long as it fits the scenario logically and algebraically, then it's a good way to go. So from here we would likely add 2 to both sides. So that's what they are showing you on this next step. So they added 2 to both sides. That would be your addition property of equality because I'm simply adding the same value to both sides. From here, again, we are simplifying, or you could say I am combining like terms. They again use this whole substitution idea, which, as I've already said, I really don't agree with, to be honest, but that's what they put, so I would allow it. I would also be okay with the word simplify or the phrase combine like terms. So any of those would be okay in my book. From here, we would divide both sides by 8. So notice they are showing that step. Guys, it's really important that you actually show every step that you are claiming to take. If you're going to use the division property of equality, then you have to show where you are dividing, right? So we need to make sure that we are showing the steps, every step of the process along the way. So we divided both sides by 8. Our reason is division property of equality. And then again, here comes the weird substitution lingo where I would have said simplify, because all you're doing right here is simplifying 32 over 8 to get 4, and you're simplifying 8 over 8 to get 1x, right? And so that's where we're coming up with our conclusion. So I like the phrase or the word simplify as a better alternative, the substitution. Let's move on. So with these are kind of nice. I hope you guys print the notes because this will make this much easier for you. All you have to do is fill in the blanks. So it's much simpler than trying to write all this out by hand. Again, here's the way this is all going to go. We now call these two-column proofs. And two-column proofs are by far the most common type of proofs that we'll be doing. Pretty much this is what we do from here on out. The paragraph proofs that we did are really more of an introduction to proofs so that you can get to this process. So as I look at this, remember what we set up above. What will you always start with for every proof? The given information. So they take the equation, they put it here. What's the reason you can always put for the first line? It's given. So that's what's been given to us. So from here, our goal is to solve. And we already know what it is that we should come up with if we do this right. Right? We are hoping to come up with x equals 3 as the last line of the proof. So from here, if we were to solve this, what would be the first step that we could take? There's actually a couple different things you could do, but I would argue that the best move would be to multiply both sides by 2 in order to cancel this guy out. So what they should be doing is multiplying both sides by 2. This must be a typo. I think that little line right there, unless they were hoping we would fill in the blank, it should be a 2. So we are multiplying both sides by 2. So that is our multiplication property of equality. And you can abbreviate it like they did. I'm totally fine with abbreviating things so we don't have to draw this out too far. As long as we can tell what it is you're saying. Like don't put MP because then I don't know if that's quite enough. Let's make sure at least we know what you're saying if you're going to abbreviate it. So we multiplied both sides by 2. From there, these two guys would cancel, and I would be left with just the 4x plus 6. And on the right side, we know that 2 times 9 is 18. So here's where they get that weird move where they would call this substitution. So if you want to put that, I'm okay with that because that's what the book says. I prefer something like simplify. So that's what I'm going to say. But I would take either one. Where do we go from there? So this is now just a two-step equation. We are going to subtract 6 from both sides. So we are clearly seeing that here and here. So we always want to make sure that's been written out. So if we are subtracting something from both sides of the equation, that is simply the subtraction property of equality. So we subtracted the same thing from both sides, subtraction property of equality. If you simplify this, here's what we would have left. I would have 4x on the left because those guys would cancel. And 18 minus 6 would give us 12 on the right. And again, they call that substitution. I would have said simplify. From here, what would we do to get x by itself? We would divide both sides by 4. So you can see on the left, they are dividing it by 4, which means I also need to divide the right by 4. And if I am dividing both sides by the same value, that is our division property of equality. From here, again, the final step, we can see that these 4's would cancel. It would simply be x equals 3, which is always what we were hoping for. X equals 3. And again, from here, I would have said simplify. They say substitution. Guys, what I would encourage you to do at this point is try this next one on your own. So this is a great place to pause the video, give this one a shot, see if you can fill in the blanks, and then play the video and see how you did. Again, we will always start with the given. So that has been written here, and we will always give the reason for that as given. So where do we go from here? There are multiple things you could do from here. So if this was not a fill-in-the-blank proof, then there could definitely be more than one right answer for this. But right now, we're going off of what they wrote. So you can see, here's what they started with, here's what they got next. They are subtracting x from both sides of the equation, right? So they're trying to get their x's onto the same side by subtracting x from both sides of the equation. So because they are doing that, that would simply be our subtraction property of equality. As far as the next move, we are simply saying that 4x minus x is 3x. So that's the left side of the equation. On the right side of the equation, x and negative x would cancel, just becomes 2. So just basic algebra simplifying. Again, I would have put simplify right there. So where do you want to go from here? They're already giving you the hint with the reason that's being stated, right? We want to subtract 8 from both sides of the equation. You do need to write that out. So we're going to say 3x plus 8 minus 8 equals 2 minus 8. So we are writing out every step of that process. Because we subtracted 8 from both sides of the equation, that is our subtraction property of equality. Where do we do from there? We simplify, right? So combine those guys, and I'm simply left with 3x on the left. Combine those guys, I get negative 6 on the right. Again, I would have said simplify. They're saying substitution. From here, we would divide both sides by 3. So you can see the work that they did. Because we're dividing, that is our division property of equality. And final step, we are simplifying. So from here, if we just do a little cleanup on the math, my 3's would cancel. I get x equals, and we know that negative 6 divided by 3 is negative 2. And voila, that's what we were trying to prove. And that's how that guy would go. So let me jump to the next page for you. So here is a better look at the 3 new properties that I mentioned on the previous page. So the reflexive property, remember, that's like looking at your reflection in a mirror. It just says something equals itself. It could be a segment, it could be an angle. As long as there's the same item on both sides of the equal sign, it's the reflexive property. You'll see how that comes up later on. That is something we'll actually use. Mostly chapter 3, though, is where we use the reflexive property. Symmetric is where you switch the order. So if AB equals CD, then CD equals AB. So I'm just switching the order. So if this is what I was given, this would be my conclusion. Works with angles as well. And then transitive we've already talked about. Works with segments, and it works with angles. So fair game for any of those. So here we go. They were really just writing a proof for this to prove the transitive property. And so we're not really going to go through all this. They're basically just trying to prove, like, here's what the transitive property would look like if it came up in a proof. So if you look at these two statements, these two things have been given to you. 1 equals 2, 2 equals 3. So just pretend for a second that the next line were not given to you. All right, so just pretend for a minute that that wasn't there. If I was doing a proof, remember your goal in a proof is always to figure out what comes next, right? Until you end up with whatever it is that you were trying to prove. So if this is what I had, and I was told that 1 equals 2 and 2 equals 3, that was my given information, I should be able to look at this and say, oh, there's my transitive property. If he equals 2 and he equals 2, then these guys must equal each other. So that would allow me to say, oh, okay, I see the transitive property going on here. So the measure of angle 1 is equal to the measure of angle 3. And I know that was because of my transitive property. So that's the way it will come up in a proof. It's something you just have to recognize, right? When I see something like this, I need to be able to come up with a conclusion like this. For the last part of this, We're just getting a little practice on recognizing those properties. Okay, so if we were told that 1 equals 2, therefore 2 equals 1, which of those three properties up above backs that up? Right? Well, if you just switch the order, we know that is our symmetric property. If 1 equals 90 and 2 equals 1, then what would allow us to say, oh, then 2 equals 90? And again, this goes back to that transitive property. If you look at these, remember in a proof, this is what you would have. This is what you have to come up with, right? So as I look at this information, I have to look at that and see, okay, well, it looks like angle 1 is 90, and angle 1 is also angle 2, therefore, I can sort of mush that together and cut out the middleman and say, oh, well then angle 2 must also equal 90. So that's the conclusion I would have to come up with. And again, that is our transitive property. Going on to this one. And again, you can always pause and try these last three on your own. We're just trying to figure out which of the three properties up above fits the description. So if AB is RS and RS is WY, then again, what's the conclusion we should be able to come up with? Because in a proof, this is what we'll see. So we need to be able to look at that and recognize that RS is being attached to both of those, therefore AB must equal WY, right? So that's the transitive property. Over here, so if AB equals CD, then half AB equals half CD. So this one was thrown as a little bit of a curveball. It's really not one of the three up above, so it looks like they wanted to just sort of squeeze one in and see if we recognized it. If you look at how did we go from here to here, like what did they do? Well, they multiplied both sides by 1/2. Anytime you multiply both sides of an equation by the same item, you are using the multiplication property of equality. And that's on the previous page. So they threw us a little curveball. That's not one of the three from up above. The next one is, though. If you're looking at yourself in the mirror, you're looking at your reflection. RS equals RS. That is our reflexive property. All right. So that's it for 2.6. We will continue on in the next one.